Let's do finite element analysis. So now we will focus on material, the input parameters to the LS-DYNA simulation. So here we have since we have here, so we will focus on this punch material, blanking, and sheet material. And here we have the temperature parameters, and here we have the elastic parameters, and this is the plastic, elastoplastic, okay, by this Ludwig formulation. So this is what we obtain from tensile testing. So Ludwig. So if I may draw the diagram, so this is the diagram. So the strain, the pre-stress value here is around 231, and start from somewhere around here, it goes up to there, and then this is how it looks like for the Ludwig. Okay, then we need to know that which one we want to assign rigid, we want to assign elastic plastic. In this case, we can use elastic bodies, but then since we want to limit our investigation to make things easy, we just use rigid. So because we don't want to see deformation occurs on the die, that's not our main interest here. We want to see what happens to this cutting area here, okay, the this area, the deformation here area, due to this elastic plastic behavior of the sheet material. So meaning that this one we assume this elastic plastic, so we will focus on elastic perfectly plastic model, perfectly plastic. And this is Holloman. This is rigid for this. And we can also focus on Johnson Cook. This is okay. All these three here is for the sheet material. This, okay. So meaning that, let me change the color. The sheet here and the sheet here. Okay, for this part. So we're going to use either this, and this. So we have three lah: elastic perfectly plastic, Holloman, and Johnson Cook. Okay, let's try this. Okay, go to LS-DYNA. You can click on this keyword manager. Okay, you go to model and part, keyword manager, and then you don't see material right around here, so you click all, and then you click collapse. Okay, you go and find material. Okay, there will be a lot of material available here, material model. So this gonna make things confused for you, so you just go straight for first we go for the rigid material. So here for the rigid material, here we're going to assign to punch, to sheet, punch, blank holder, and die, right? So we go to rigid, try to search rigid, number 20. So click new, and then click rigid, and you enter the value. Let's say here we use 0.8, 0.9, so 7.9, E minus 9, and then we're going to put in this elastic yang modulus 2.06 or 2.1 is okay. E let's say we use the value written here. So here's we choose one, let's say for the punch 7.73, and then here are 230 e power of 3, and the Poisson ratio is 0.3. okay, then you click accept, you have reached it. Okay, now you go for power law. Okay, since we're going to that we go for kinematic hardening first. Wait, then material number 3, yeah, material number 3, material number 3003, yeah, there. Okay, so click new. Okay, this what you said, elastic perfectly plastic. Okay, then raw is here. We use for sheet material we use 7.9 e minus 9. Elastic properties 200 e power of 3, and the Poisson ratio 0.3, and the 6 sigma, if you remember, this is 231, and this one, if we assume there is some angle to the deformation, so failure strain we decide it to be 1. Let's say 1.6 lah, it's okay, or maybe 2, it's okay, we decide to be 2. Okay, failure strain, and then accept. Okay, accept. The strain rate parameter not important. Failure strain, for this one, failure strain is very important because of the shearing and fracture, so this is important where the elements start to erode. Okay, so start to erode when the strain value reach this the effective strain value reach this failure strain value. Okay, that's what we get. Okay, now we are enter the other value where we want to focus on power law, Holomon. So we set this here, we see this is Holomon. So then the number 2.7, 2.9 e9 for the density, 200, this one power of 3, 0.3, and the load weight here 1339, we can just copy. Okay, and here we have the strain value 0.594, and here is the strain rate. We don't want to focus on strain rate, so this strain value 231. Okay, so this one is not okay, so here we consider at 2.0. so click accept, Holomon. So then we will focus on Johnson Cook. Where we're going to set the Johnson Cook to be in this case, let me just look here, what did I choose? I think simple one. This is simplified Johnson Cook. Okay, you can also choose this one. So here you see Johnson Cook, where you don't want, because why did I choose this one 0. Click accept. So instead of choosing this, why did I choose 0.98? This is include the damage properties. So because this damage for D1, failure property D2, D3, D4, D5, I don't have this data, and we don't want to go that far, since this is up to I think this is master level. Okay, or maybe if you take the special course in the final year, so you can learn this. But for today, we just limit up to this simple model, simplified Johnson Cook, and the density here 7.9, so E minus 9. Here elastic 200 E3, and here 0.3, and this one the important A here is the this one A, since this is similar to Ludwig, right? So this is B, this is B, this is N. Okay, this C here, the C here is the for the strain rate, so we leave it as 0, since we don't want to consider the strain rate. But the effective plastic strain at failure, this is the one where we want it to be 2.0. Okay, so the rest not important. Maximum stress optimal from work hardening we have already added, so this one we leave it as default. So then accept, and then collapse. Okay, so then what you need to do is that you click model and go to part and click part, and then punch here. You want it to be punch rigid, right? Okay, select rigid, and then you click accept, and then you go to sheet. We want to focus on elastic perfectly plastic. You click here. We have another two models. Okay, so but first we choose this. Later we will see the effect if we will run the simulation differently and using 3 different materials. Okay, accept, and blank holder here we choose rigid. Accept. Die here, you click on this is material ID, you go to Johnson Cook, click done, and then accept. Okay, now we are finished with input parameters for the material.